This is a video walkthrough for practice 6b. In our first think about it question, we're asked how is adding polynomials and adding radicals similar to each other. So when we add polynomials, only like terms like 6x squared and 7x squared can be combined. When we add radical expressions, only like terms 6 squared of 2 and 7 times the square root of 2, for example, can be combined. In question 2, we are asked when you square a binomial such as the square root of 3 plus 5, the quantity squared, can you just distribute squaring to each term? Why or why not? And the answer is no, you cannot. And this is because exponents do not distribute to addition or subtraction. Instead, partial products must be found and added together. And partial products refers to a technique like the FOIL method or the box method, where many, for instance, in a binomial times a binomial, you find each of the partial products, first outers, inners, last, and add them together. In 3 through 26, we're asked to perform the indicated operations and simplify completely, and we may assume that variables represent positive numbers, so we're not going to see the use of absolute value when simplifying a radical here. So in number 3, we need to simplify each radical individually first. So square root of 8 can be factored into square root of 4 times the square root of 2, which simplified is 2 times the square root of 2. Square root of 32 can be simplified. The largest perfect square that divides evenly into it is 16. So square root of 16 times square root of 2, and that's 4 times the square root of 2. So now that we have like terms, we can, or like radicals, we can combine them. 2 times the square root of 2 minus 4 times the square root of 2 is negative 2 times the square root of 2, just like 2x minus 4x is negative 2x. In number 4, we now have a variable expression that we need to simplify. And inside the first radical, we do have a perfect square factor. And that perfect square factor is x squared. And that leaves us with a 2x. So simplifying the first term, we just have 2x times the square root of 2x. Now let's simplify the second term. So we have 4x. And then a perfect square factor that divides evenly into 8 is 4. So square root of 4 times square root of 2x. No perfect square factors left over. And the square root of 4 is 2. 2 times 4x is 8x. So now we have 8x times the square root of 2x. And now we can combine the like radicals together by adding their coefficients. So that gives us 10x times the square root of 2x. In number 5, we have 3 radicals, which may be able to be combined if we simplify them. So I'll bring down the 2. The square root of 50 contains a perfect square factor of 25. So that first radical can be simplified to 2 times 5 times the square root of 2, or 10 times the square root of 2. 125 contains a perfect square factor of 25. And that leaves us with a square root of 5. So this term simplifies to 3 times 5 times the square root of 5, which is 15 times the square root of 5. And then the last factor, or the last term, has a perfect square factor of 49. So the square root of 49 times the square root of 2 is 7 times the square root of 2. Now we can combine the like terms, or the like radicals, together. 10 times the square root of 2 plus 7 times the square root of 2 is 17 times the square root of 2. And then minus 15 times the square root of 5 may not be combined since we have unlike radicals. In 6, we have some variable expressions and cube roots to simplify. In the first term, we have a perfect cube factor of 8. So we have cube root of 8 times the cube root of 2 times x. And let's simplify that further. That's 2 times the cube root of 2x. And then in 54 is a perfect square perfect cube factor of 27. So the cube root of 27 times the cube root of 2x is 3 times the cube root of 2x. Now if we have 2 times the cube root of 2x minus 3 times the cube root of 2x, we can combine them by subtracting their coefficients. So 2 minus 3 is -1. Typically when we write a multiplication by -1, we do not include the number 1, we just include it, the expression as the opposite of the cube root of 2x. In 7, we have 3 radicals to simplify and square roots. In the first term, we have perfect square factors of 9 and also b squared, so that will leave us with an extra factor of the square root of b. Simplifying, that's 3b times the square root of b. And then in the second term, we have perfect square factors of 25 and also b squared, which also leaves us with a leftover factor of the square root of b. So that simplifies to 5b times the square root of b. And then the last term, it also has perfect square factors of 49 and b squared, which leaves us with a leftover factor of square root of b. And so that simplifies to 7b times the square root of b. Now, since all terms have a like radical in them and like coefficients, that is, they're all multiplied by b, we can combine them all together. 3b minus 5b is -2b, plus 7b is positive 5b times the square root of b. In 8, we have some like radicals but unlike denominators. So I'm going to start by multiplying 5 times the square root of 5 times the square root of 2 over 3 by 5 over 5, which will give us a common denominator. And then I'll multiply 2 times the square root of 2 over 5 by 3 over 3, which will give us that same common denominator of 15. So now let's write our equivalent fractions. Multiplying numerators, we have 25 times the square root of 2, and multiplying denominators, 15. For the second fraction, multiplying numerators, 6 times the square root of 2, and multiplying denominators, 15. Now we can add together the numerators. 25 times the square root of 2 plus 6 times the square root of 2 is 31 times the square root of 2, and we keep that denominator, which is 15. In number 9, we have cube root expressions to simplify. So we can start by distributing the cube root to the division in the first fraction. That will give us the cube root of 11 divided by the cube root of 8, which is 2. And then minus, and I'm going to leave a little space here, minus the cube root of 11 over 6. Now we're going to need a common denominator in order to be able to subtract. So I'll multiply the first fraction by 3 over 3 to give us a common denominator of 6. So now we have 3 times the cube root of 11 over 6 minus the cube root of 11 over 6. And the understood coefficient on that second fraction is 1. So when we subtract numerators, 3 times the cube root of 11 minus 2 times the cube root of 11 is 2 times the cube root of 11. And that's over 6. We keep the denominator. Now we can reduce, because remember that 6 is 2 times 3, so we can cancel those common factors of 2, and we get a final result of the cube root of 11 over 3. In 10, we have 7 times the square root of 9 as the first term, which is just 7 times 3, minus 7 plus the square root of 3, and neither of those simplify. 7 times the square root of 3 is 21, or 7 times 3 rather is 21, minus 7 plus the square root of 3. Combining like terms, 21 minus 7 is 14, plus the square root of 3. We cannot combine our like terms there because, we cannot combine because we don't have like terms. One has a radical and the other term is not multiplied by a radical. So that's the final answer. All right, in 11, we need to do some simplifying on these radicals first. So 2 plus 3 times the square root of y squared is y, as long as y is a positive number. And then minus 6 times the square root of y squared, which would be y, plus 5. And I've written something incorrect. Sorry, in that second term, 3 times the square root of y squared, that's the same thing as 3 times y. And now we can just combine our like terms. 2 plus 5 is 7. 3y minus 6y is negative 3y. And now we've combined all the like terms together. All right, in 12, we have some radicals to simplify here, cube roots this time. And 125 is a perfect cube factor of 625. It goes in 5 times. So when we simplify this first term, that's 5 times 5 times the cube root of 5. And further simplifying, that's negative 25 times the cube root of 5. And then the cube root of 40 has a perfect cube factor of cube root of 8. Cube root of 8 times cube root of 5. So that's plus 2 times the cube root of 5. I'll just bring that down. And now we can combine our like terms. Negative 25 times the cube root of 5 plus 2 times the cube root of 5 is negative 23 times the cube root of 5. In number 13, we'll have to simplify each radical here first. In the first radical, we have a perfect cube factor of 27 that divides evenly into 54, and also y cubed. The leftover factors are 2 and x. So, further simplifying that term, we have the cube root of 27y cubed, which is 3y, times the cube root of 2x. Now let's simplify the second term. I'll bring down the minus 5, and inside that radical, we do have a perfect cube factor of y cubed. So that's the cube root of y cubed times the cube root of 2x. And now let's further simplify that. That's 5y times the cube root of 2x. And in the third radical, I'll bring down the y, and we have a perfect cube factor in 128 of 64. And that leaves us with a cube root of 2x as a leftover factor. Simplifying that term, cube root of 64 is 4, so 4y times the cube root of 2x. Now, since all the radicals have the same radicand, we can combine by adding or subtracting coefficients. So 3y minus 5y is negative 2y, plus 4y is positive 2y, times the cube root of 2x. In number 14, we can start by bringing down the 2 coefficient, and there is a perfect fourth power in x to the 7th, that's x to the 4th, and we have leftover factor of x cubed. Let's continue simplifying that term. That will give us negative 2x times the 4th root of x cubed. And then for the next term, bring down that factor of 3, and we have a perfect fourth power of 16, and another perfect fourth power of x to the 4th. That gives us a leftover factor of x to the 3rd inside that radical. So simplifying, the 4th root of 16x to the 4th is 2x, and that's times 4th root of x cubed. Simplifying a little further, negative 2x times the 4th root of x cubed plus 6x times the 4th root of x cubed. And now we can just combine coefficients, and so that's going to give us a total of 4x times the 4th root of x cubed. Okay, in number 15, we can start by distributing the square root to the numerator and denominator of that first fraction. Square root of 28 can be factored to square root of 4 times the square root of 7, and the square root of x squared is just x, assuming that x is a positive number. So now that term simplifies to 2 times the square root of 7 divided by x, And then our second term, we'd do the same thing. Distribute that square root to the numerator and denominator. So the numerator is square root of 7, and the denominator square root of 4x squared is 2x. So that second fraction has a different denominator, which means that we are going to need to multiply this first fraction by 2 over 2 and get a result of 4 times the square root of 7 over 2x plus the square root of 7 over 2x. And now we can just add our numerators, 5 times the square root of 7 over the common denominator of 2x. In 16, we can distribute the cube root over the numerator and denominator of the first fraction. 16 has a perfect cube factor of 8, so I'll factor the numerator into the cube root of 8 times the cube root of 2. And downstairs, the cube root of 27 is 3. And then minus the cube root of 54 on top. Now 54 has a perfect cube factor of 27, so the cube root of 27 times the cube root of 2, and then downstairs a 6. All right, so now what do we have? We have a 2 times the cube root of 2 over 3 minus 3 times the cube root of 2 over 6. We want a common denominator here, so I'm going to multiply this one by 2 over 2, and that will give us a result of 6 times the cube root. Sorry, that's going to be, numerator is going to be 2 times the cube root of 2 times an additional 2, so that gives us 4 times the cube root of 2 over 6 minus 3 times the cube root of 2 over 6, and that gives us 1 cube root of 2 over 6. In 17, we can begin by distributing the square root of 7 times the square root of 5 as the square root of 35, and the square root of 7 times the square root of 3 is the square root of 21. Neither radical is able to be simplified, and so that's our final answer. In 18, we have to square a binomial. You may want to write this out, the square root of 5 minus the square root of 2 times the square root of 5 minus the square root of 2. Don't just distribute the squaring. So product of the first is the square root of 5 times the square root of 5 is the square root of 25. Product of the outers is square root of 5 times negative square root of 2, which is negative square root of 10. And the inners is the same product. And the last is positive, negative times negative, square root of 4. So now we have 5 minus, and the two middle terms combine to 2 times the square root of 10 plus 4. So that gives us 9 minus 2 times the square root of 10. Sorry, I made a boo-boo. Let me go back and fix that one. The square root of 4 is 2. And now combine like terms, and we have 7 minus 2 times the square root of 10. For 19, we can multiply by distributing the multiplication over the subtraction. Square root of 3 times x times the square root of 3 is the square root of 9 times x, and the square root of 3x times the square root of x is the square root of 3x squared. Now let's simplify each square root. The first has a perfect square factor of 9, so we can take the square root there and leave the x in the radical. The second has a perfect square factor of x squared, so we can take out the x and leave the 3 in the radical. Now we have unlike radicals. They may not be combined, so this is our final answer. In number 20, I'm going to multiply these two binomials by foiling. The product of the first is 6 times the square root of x squared. The product of the outers is 1 times 2 times the square root of x, so that's 2 times the square root of x. Inners, that would be minus 15 times the square root of x, and last, negative 5 times positive 1 is negative 5. So now let's simplify the first term, 6 times x, and then combining the like terms in the middle, since they're like radicals, minus 13 times the square root of x, and minus 5. In number 21, we have some partial products to compute and add together, in other words, the FOIL method. The product of the first terms is the cube root of a squared. The product of the outers plus 5 times the cube root of a, and the product of the inners minus 4 times the cube root of a, and then the product of the last is minus 20. The cube root of a squared can't be simplified because the index is larger than the exponent under the radical. So we're going to leave that term alone. The terms in the middle are like radicals. They're both the cube root of a. So 5 cube root of a minus 4 cube root of a is positive 1 cube root of a. We don't write that coefficient. 1 times the cube root of a is just the cube root of a. And then minus 20. And no other terms can be combined. In number 20, we can simplify by using the distributive property of multiplication over subtraction. So this is equal to 6 times the square root of 2 minus 12. Unlike terms, cannot simplify further. One has a radical that's being multiplied and the other does not. In 23, we can multiply by using the distributive property. Square root of 2 times square root of 2 is square root of 4 plus, and then in the second multiplication, the x is outside the radical, so we can't multiply. But the square root of 2 and square root of 6 can be multiplied together to give us square root of 12. Square root of 4 is 2, and the square root of 12 has a perfect square factor of square root of 4. That's going to leave us with a square root of 3 left over. So now we have 2 plus 2 times x times the square root of 3. In number 24, we want to multiply the square root of 3 plus x times itself, since that's by definition what squaring means. And then compute the partial products, or use the FOIL method. The square root of 3 times the square root of 3 is the square root of 9. The product of the outers is x times the square root of 3. The product of the inners is the same. And the product of the last is x times x is x squared. So now we have 3 plus, and then the two middle terms can be combined. 2 times x times the square root of 3 plus x squared, and no other terms can be combined. In 25, we need to multiply by using partial products again, which is sort of a modified FOIL method. So I'm going to distribute this first term to each of the terms in the trinomial. And so let's do that first. The cube root of x times the cube root of x squared is the cube root of x cubed. And for the second term, the cube root of x times the cube root of x is the cube root of x squared. And for the last term, cube root of x times 1 is the cube root of x. Now let's distribute the second term. 1 times the cube root of x squared is the cube root of x squared. 1 times negative cube root of x is negative cube root of x. And 1 times 1 is 1. Now we're going to notice that we have several like terms here. We have a negative cube root of x squared, and we have a positive cube root of x squared. Those add up to 0. We also have a positive cube root of x and a negative cube root of x. Those also add up to 0. So that means only the remaining terms need be simplified. The cube root of x cubed is x, and the last term is plus 1. So that's the final result. You might notice that this resembles the sum of two cubes factoring. In 26, we're squaring a binomial, so I'm going to write this out as the square root of x minus 1 plus 5 times the square root of x minus 1 plus 5. Adding together all of our partial products or using the FOIL method, the product of the first is the square root of x minus 1 squared, and the outer product is 5 times the square root of x minus 1. The inner product is the same. And the last product, 5 times 5, is 25. Now let's simplify. Assuming that variable quantities represent positive numbers, The square root of x minus 1 squared is just x minus 1. The middle two terms are like radicals. They can be combined to 10 times the square root of x minus 1. And the last is plus 25. We have one more set of like terms to combine. Minus 1 and positive 25 give us a term of positive 24. And no other terms can be combined. In number 25, we're asked to find the perimeter and area of the rectangle shown below and write all of the answers in simplified form. The perimeter is just, in fact, adding together all of the sides of a closed figure. So the perimeter is 3 times the square root of 20 plus the square root of 125 plus 3 times the square root of 20 plus the square root of 125. Not just the sides that are labeled, but all 4 sides of that rectangle. Let's combine our like terms together. That's 6 times the square root of 20 plus 2 times the square root of 125. Now let's simplify. The square root of 20 has a perfect square factor, square root of 4. So that's 6 times 2 times the square root of 5, which is 12 times the square root of 5. And in the second term, we have a perfect square factor in 125 of 5. That leaves us with a square root of 5 left over in the radical. Square root of 25 is 5 times 2 is 10, so now we have 10 times the square root of 5. And adding those together, that's 22 times the square root of 5, and the units here would be in feet because perimeter is just a measure of length. When we are finding the area is just length times width, so we can just multiply these two length and width together, but let's simplify each first. You can simplify first and multiply together or vice versa, but it might be easier to do the simplification when we have smaller numbers. So remember, this can be simplified as 3 times the square root of 4 times the square root of 5, so that's 6 times the square root of 5 is the length, and the width here is the square root of 125. Remember, that's the square root of 25 times the square root of 5, so that's just 5 times the square root of 5. So now we really have 4 things to multiply together. Don't really pay attention to the parentheses. Don't think that you need to FOIL because that's for a binomial times a binomial. This is really just 4 things being multiplied together. And when you multiply, you can multiply in any order. 6 times 5 is 30. The square root of 5 times the square root of 5 is the square root of 25. So now we have 30 times 5, which is 150. And of course, the units of area would be square feet.